Hi, in this video we're going to talk about the useful formulas of analytical geometry. Now, analytical geometry combines algebra and geometry to study geometric shapes and their properties using coordinate systems. So the coordinate system we use here is the Cartesian plane, and mostly we're doing a study of lines. So this can range from parallel lines to perpendicular lines. All of these lines, there is some formula that has something to do with lines. Along with shapes as well, we have rectangles, we have parallelograms, and the critical point of it all is that they all have coordinates. These coordinates can allow us to calculate things such as the distance from A to B. Doing so, we would be using the distance formula. So the distance formula is as follows. If you want to calculate the distance, you will take the square root of, since this is a coordinate system, we have XA here and YA. And then we have XB and YB. So the distance will be, let me write that in black, our distance will be the square root of the difference between either XA minus XB or XB minus XA, whichever one you start with when you do the X part, square that, is the same order you have to take when you're doing the Y part of it. So YA minus YB, square that as well. So this is the distance formula. But what if I'm looking for, let's say, the midpoint between A and C? So I'm looking for the midpoint, which would lie somewhere over here. We can call that point M. So AC would be this line over here, meaning this will be XC and YC. Therefore, if we're looking for the midpoint, we use the following formula. M, then we have the addition of XA, the two X coordinates that we are adding up, along with the two Y coordinates of those same 2 points. So YA, YC over 2, and we have that. This is how we find the midpoint between or of any any line. Then we have lines themselves. These are straight lines. We can actually find, let's say, the gradient of BD like that. So this would be XD and YD. All these are standing in place for actual coordinates or actual values. And then we have lines. We have a lot of rules on lines. We can calculate the gradient of lines. So that would be something like the change in Y over the change in B. So YB minus YD over, again, the same, you're supposed to use the same convention. So YB minus YD will be similar to over XB minus XD, like that. So this gives us the gradient of any line. But once we have that gradient along with these coordinates, we know that we are able to find the line. So the equation of the line, y is equals to mx plus c. Or another one that's used in this context is y minus y1 is equal to mx minus x1, where y1 and x1 refer to any points. Let's say we're trying to find the equation of line BC. So BC here would be this dotted line joining the 2 points. Therefore, that would be y minus the y at B is equals to the gradient that you would calculate of BC, x minus, since we used YB, we're supposed to use XB as well. So you can either use this point at B or you can use the point at C. Whichever one you use, it doesn't matter, as you will come up with the same answer. Then what about lines themselves? How can I test if two lines are parallel. So if I work out the gradient of AB and I work out the gradient of CD, knowing that this is a parallelogram, what am I supposed to come up with? So for parallel lines, we have that the gradient of AB will be equal to the gradient of CD. And for perpendicular lines, although we don't have any perpendicular lines in our drawings, we can set the rule for them as well. For perpendicular lines, we have it that if we take the gradient of one of the lines multiplied with the gradient of the other line, we are supposed to get -1. So if you don't know anything about two lines, right, and you're trying to find are they perpendicular, then calculate their gradients and then multiply them together. If you get -1, it means they're perpendicular. But if they are not giving you -1, then they won't be perpendicular. Another tip is that if you know that the gradient, let's say you have two lines, right? You have your Cartesian plane and you draw two lines on this Cartesian plane. And you know for a fact that these two lines are perpendicular. You know the gradient of one, so this gradient, I'll say this is m1 and this is m2. You know that m1 is equal to -2/3. How can you quickly get the gradient of m2 knowing that m1 is -2/3? First of all, you change the sign and then you swap the denominator with the numerator. So 3 goes on top and 2 goes at the bottom, such that this gradient will be 3/2. And if you multiply these two gradients, so m1 multiplied by m2, that will give you -2/3 times 3/2. 3 and 3 cancel, 2 and 2 cancel, you're left with -1. Therefore, can you see that this property actually holds true? Then that is it for the useful formulas that we normally use during analytical geometry.